Good afternoon today. Welcome to class, everybody. Thank you for joining me, whether you're watching live or you're watching the recording. I just appreciate you watching, taking the time and learning a little bit more about the queries that we write to interact with our databases. So we are working through Module 3 a bit more today, which is great. Before we start on our new stuff today, I wanted to just take some time and review kind of where we ended up last week. So I actually saved the queries where we ended up last week. So at the end of class last week, these were the final queries that we had written in our MySQL Workbench DBMS. And we can kind of go through just each of these queries and we could talk about, we can pull out each of the little parts that we did here and talk about each of the little pieces that we have here before we get into the new stuff today. And so the first thing that we talked about is we went back and we revisited one of the things that we, have kind of been talking about from week 1, and that's this idea of being able to select everything from a table. Right, and that's where we used our asterisk selector. Select star from players here, which is what we're doing here on line 1. And we said, especially in this course, right, with where we're at, getting started here with learning how to use MySQL, learning how to interact with databases in such a way. Queries like this are really going to be our friend as we're getting started, right? Like these our homework data set that we're using is a really manageable data set. We're not talking about, very large data sets here. So it's a very small data set that we're working with. And so as such, right, like we can go back and we can kind of check ourselves and make sure that we got things right just by kind of going through and looking at the data set and making sure that, what we can kind of go through and reason in the data set is the same thing that we're getting out of the query that we wrote from our data set. And so just using this select star from players or select asterisk query and getting an understanding of our schema before writing a query is a pretty big deal. Now, if we were using a large data set, something that I would do, right, because, one of the things that we've said is that we use this, since we're using a small data set here, I can see and I can kind of get a lay of the land of, like, all my columns and stuff. We need to make sure that we're using our database here. I just opened up my database. So we're going to use tennis here. There we go. And so one of the things that, we've talked about here is this idea that, I can use this select star from players to get an idea of, okay, well, I can see I got player number, I got name. I can kind of see the schema. Right, and this is all well and good for when I am, when we have this sort of small data set. Right, however, if I were dealing with larger data sets, one thing that I might want to use instead would be a describe command. So let's try to describe players here and see what our difference would be. So when we run describe players, this is the description of players. And the description of players gives us specifically the schema that's set up by players. So it doesn't give us the full table with all the data, right? Which is something that we've said before, is that, when we have a bunch of data and a bunch of columns especially, that the more data that we have and the more columns of information that we have that we're trying to kind of pour through and pull information from and trying to figure out, what's going on here, it kind of creates more noise, right? So the more noise that we have, the more cognitive information, it gives us, and it increases our cognitive load, and it kind of clouds what we're doing. So it kind of makes things harder to understand when we're trying to get a picture of, well, what are our columns? What are we trying to select? What are we really trying to do here? Whereas if we use our describe command specifically goes through, and you can see what it gives us here, right? It gives us our column titles. It gives us our data type that's in those column titles, and it lets us know which one is set to be the primary key here, in addition to whether or not they were set to be null or not null. So typically I would use this, our select star, as we've been doing with a smaller data set, and I'd use describe with a larger data set just to try to limit the amount of noise as I was trying to get an understanding of the schema for a particular table. Because select star returns everything from a table, so I might not need all this information. And the second query that we have here, we're selecting star from players, and then we have a where statement. And our where statement is kind of like a conditional in other programming languages. So if you remember back to when we worked in Python or JavaScript or one of the many programming languages that we've worked in the past, we would use a conditional, and a conditional would allow our programs to make a decision, right? In those cases, we would use an if statement, and we would say, if some condition is true, then it would execute a predefined bit of code. And our where statement here is very similar, right? We're saying, where these conditions are true, return this data, basically, right? So where town equals Stratford, in this instance, or player number is greater than 99. So we have a compound condition here. So in this instance, this is our third output query at the bottom. So we are getting an or compound condition here, meaning either condition can be satisfied as true by the record for it to be returned. So either the record's town value is set to Stratford, or the record's player number value is greater than 99. And so if we look at our results for that query, we can see below player number of 99, all the town values are Stratford. Once we hit player number 100 here, we can see at that point we get different town values returned in that column. So that's just a condition, right? From there, we actually started to get more specific to where we said, well, we don't always need all information from a record, right? Sometimes we only need some of the information from a record. So in our third query here, we're only selecting the initials, the name, and the birth date. So in this case, those are the initials, the first initials, the last name, and the birth date from the same players table. And we have a compound condition again, but in this case, our compound condition uses an AND clause, which means that both of these statements must be true in order for this record to be returned. So in this instance, the record must have a town of Stratford and a player number of 99. And since our data set is small, And we know our data set relatively well. We know that P. Parmenter, born on February 28th, 1963, is the only person that meets this set of criteria. So if we look in the set of results here for that, we see P. Parmenter's information there. And finally, we introduced the concept of an alias right there before we left, before we ended the stream last week. That's this as value here. And that just allows us to bring back a column just with a more descriptive title than you might receive it otherwise. Right, so in this instance, we gave this birth date column. Right, we can see by default, if we're calling for the birth date column, we get the title of the column just as it was created when we created the table, which is birth_date. But we changed it here to date of birth. Now what you see here surrounding this phrase are not single quotes. These are tick marks. That is the key above the tab key on your keyboard. There, we're going to wrap our string here in tick marks for our alias. We can do another example of an alias here for name, since this name in particular is not just name, it's last name. We can say as tick mark last space name, and that will change the name in the header on the output. And that does absolutely nothing, right, to actually change the title of the column in our database, right? It leaves the column in our database alone. It just gives that column an alias on output so it can make more sense to us as we are reading our results, because that's one of the things that we are trying to do here, right? Like, one of the things that we've kind of said, and one of the analogies that I actually made to the CTI 110 classes I was teaching databases this past week was the idea of, we have this database and we have all this data in our database, and all this data in our database, it's kind of like, you see a mountain, and, inside of that mountain, who knows what's inside of that mountain, right? Like, could be gold, could be jewels, could be absolutely nothing, right? And you won't know until you mine the mountain out, or mine a certain plot of land out that might be known to maybe be gold rich, right? So our our data in our database, that's just zeros and ones. It's just binary on a hard drive. Right, and we don't really get data, we don't really get important information until we run it through a process, until we do some queries with it, and we get information back from it. And so the information that we get back from it, we want it to be super descriptive. We want it to be meaningful. And so the more that we can do with something like this, then the better off we kind of are. All right, so I'm going to go ahead and remove these queries from here now. We've got those done. We'll kind of swap back over to our presentation. And remember that, kind of part of our presentation is that, we are looking at different problems and talking about how we can use different problems, or how we can write different queries to solve our different problems. And so now we have these queries, right? And we started out from being able to bring in a lot of data, right? We could just take all the data from a table and bring it back to us. And then we got to where we could bring back some really specific pieces of data. But one of the things that you might have noticed was that, kind of regardless of how specific it was, everything kind of came back in just the order that it was put in the database, right? Like it's the same, it's in the same order here as it is here, just by default. So what if we want to use some kind of query to, give some kind of different order to this database? And that's where our order by clause comes into play. Right, so if we want to display the results of a particular query in a certain order, we use our order by clause. So one of the things to remember kind of as we're going through all of this, right, is that we're just kind of adding pieces to existing queries. Right, so the things that we've done before, all of those still exist. None of those have changed. We've not gotten rid of any of those. All of those still exist. We are just adding to them. So the order by clause, what it allows us to do is it allows us to order the rows of our result set. And so by default, we order things in ascending order, but we could also order things in descending order. And so if we look at a sample query, we could look at one here. Right here we see, as we can select customer ID. In this case, we're selecting 4 things, right? Customer ID, address, city, and postal code. And we're pulling that postal code back with an alias of zip code. So when we get that postal code back, instead of saying postal code, more colloquially in the United States, we call it a zip code. So, there's that. So we're pulling back customer ID, address, city, postal code, or zip code, rather. From customers, where customer ID is greater than 50 and country is USA. Order by customer ID descending, DESC. So we're ordering by customer ID, but we are reversing it, and we're going from big to small in this instance. So what this is going to pull back for us is it's going to pull back for us 4 columns of data: customer ID, address, city, and zip code from a customers table. And remember that these, sample queries are from a hypothetical store table here. We're in this table. We're looking for customer IDs greater than 50. So any customer IDs from 51 all the way up to positive infinity, hypothetically. And the country code, they're from being the United States, USA. And then we're going to take those and we want to order them by descending. And maybe we want to do that because maybe we want to see the newest customers first. Maybe early on we ran some promotion where we sent our earliest United States customers some sort of free gift or some sort of advertising or some sort of something, right? But, we only did that for our first 50 customers or whatever, and now we want to take our most recent customers, but we want to start with our newest customers because they're the ones that were in the stores most recently, and we want them to, convert to a lifelong customer or whatever, right? Like, logic there's beside the point, right? You'd actually think these things out before you did them. But we can order by many different things here. So if we had a look, right, the first thing that I want to do here is I just want to write a simple query that's going to take and look at our players table. So we're going to select star from players just so we get an understanding of what's going on there. Right, let's say I want player number, name, and initials. So I'm just going to get every name here. So we're going to select player number, name, and initials from players. And we're going to order by player number. Now, by default, it's going to order by ascending. So I don't really need to worry about this. Right, but let's reverse it, right? Let's order it by descending. So that is DESC. And just for our purposes here, let me make sure that all of my words that I'm using here that are my SQL words are all uppercase, just so they are all differentiated for you all. So we're selecting player number, name, and initials. So our player number column, our name column, and our initials column from our players table. Let's give this a run. And so there we see we have our same table, but all of our records are inverted now, because instead of starting with to Everett R, which is the default, right? Because that's the way the table was built. Then we ordered it by player number descending. Now let's try something here just to see what it does. Let's try to order it by our strings. Let's try to order it by name. And run it. And we can see here that it still works, right? It puts everything in alphabetical order. So it actually doesn't matter if it is a string or an integer. It's going to work here for us. And we actually have all of our player names organized in alphabetical order. So if I wanted to take my player names and I wanted to organize them in alphabetical order, and I wanted to find out who are the players that come last alphabetically, well, order by name, and then let's flip the list and say descending. Right? Because I can select the player number, the name, and the initials from players. Order by the last name. But then we're going to flip it with our descending modifier here. And uh-oh. It doesn't like that. And I think that might be specifically because this is a column called name, and name is otherwise a keyword in MySQL, so it might be smarter for us to use the table modifier here and call it players.name descending. Because once we do that, we see that it works. All right, and we get that Y is in Parmenter and Parmenter P in Newcastle, right, on our output here. Is what we want. One of the things that you probably have noticed, right, is that when we type in name on its own, is that name kind of comes up in a different color. But it's still workable here. So using players.name allows us to do that. Now let's get even more specific, right? What if I wanted to get even more specific? What if I wanted to say, okay, well, let's pull Parmenter P and Mormon D out of here, right? Let's say I want to get these players, and I want to say, well, where player number is less than 100. Right, so as we can see here, like the more that we add these little pieces to it, right now we still have these all sorted up. Right, we're selecting player number, we're getting our player number, we're getting our name, we're getting our initials. From our players table, where our player number is less than 100, and we're ordering by our players.name descending. And so now we have all of our players that have a player number less than 100. And then we're taking all of them and we're ordering them by their last name from in reverse alphabetical order, right? Which is giving us this result, which is correct, right? Well, like we can look at it and we can see that it's correct. Now let's say that we only want, maybe the first three, right? Let's say we want it to limit our results to 3, right? We only need to see a certain number of results. If we want to only see a certain number of results from our query, we can use the limit clause. So this just lets us limit the number of rows to be returned from a query, and we just add limit and the number of results that we would like to see to our query, right? So in this case, we're just adding limit 3 here. So if we only want to see the top 3 results here, we can just limit this, limit 3 or limit 4. And it's only going to limit this to the first 3 results. And so what's a potential benefit to this? Well, maybe if I had a leaderboard and I had to pull back the winners, everybody's on the leaderboard, right? Everybody's in the database for the leaderboard, but only 3 people are at the top of the leaderboard. So if I had my leaderboard ordered by the number of points, and then, in ascending order, and then I had it limit 3, so it's only returning me the first 3 results, then I have my top 3 people on my leaderboard right there, right? And it's just completely automated, right? Based on scores that are in the database. Without having to do anything manually. But as we progress and as we're kind of taking each of these little pieces and we're adding them to our repertoire of little tools that we have that we can use to add a little bit more to our query and a little bit more to our query, things do kind of get a little bit tougher and a little bit tougher to kind of remember, right? Because we have so much to remember, but they're all just little bitty pieces. Right, well, what if I want to do this? Well, then I do that. And what if I want to do this? Well, then I do that. And what if I want to do this? Well, then I do that, right? And so it's actually not so bad. Now, this next problem that we have that I want us to talk about is a little bit challenging, I think, for us to kind of wrap our heads around. It is a little bit tough for us to kind of understand. But I don't necessarily think it's that difficult of a concept. I think we just have to kind of, I think once we play with it a little bit, it's easier for us to figure out. And that's the idea of using in and not in. And that's when I have a list of qualifications. Right, so basically I have a set of data points when I'm thinking about using in or not in. I have a set of data points, and I can say, well, I'm looking for all the records with a specific data point that is in this set of data points. So we're going to use that where clause again, right? Because that's our conditional operator for MySQL. So we're going to use that where clause. But in this case, we're going to add multiple values that the item could be in order to return the condition as true. And that's basically our in clause. So where our in operator kind of allows us to set up multiple or conditions, right? If we have a where clause, we can typically have just like one and or in general. But if we use an in or a not in, which is an inverse of an in, then we can basically get a multitude of or statements in one statement. So if we look at an example here, select star from customers where city in Paris, London. Right, so what we're really saying here, right, is to return all records from customers where the city of that record returns the value Paris or returns the value London. Right, we can see that, we have the parentheses surrounding Paris and London again. Right, and one of the things that we said last time was that if we see something in parentheses in MySQL, then that typically means to do them together. So we're going to be evaluating Paris and London together here. So this is going to be one or the other that we're dealing with here. Now we can also get a little more complex with this. Right, like this is a really basic example of this, and we're basically just saying, okay, well it could be this or that, right? Like we could just as easily write this as select star from customers where city equals Paris or city equals London, right? And that's the exact same result. It's a little more wordy, which is a little less efficient, but it's the exact same result. Now, if we were to look at something like this, right, this is where we're getting the real power here of our ins and not ins, right? Because we said that we're only really allowed to have one of these and or statements. Right, well, we've used an and statement here to connect an in and a not in. So in this instance, we are selecting star from customers. So we're selecting everything from our customers table, where country is in UK or France, and city is not in London. So let's talk about what this query does. Right, so we're returning everything from the record, right? So there's no specific data being returned from a particular record here. It's just all items in the data record. We're country in UK or France. So that means that the country column for the record is going to either have UK, United Kingdom, or France as the data value. However, what must also be true is that the city in the city column should not be London. All right, and this is where this kind of gets a little bit tricky, right? Is this whole idea of not in and not in. Because we're looking for it in relation to like this set of data. It's not in this set. So when we look at this statement here that we're looking at, this query that we've written here, we're basically saying, okay, well, any country that is the UK or France, right? France or the United Kingdom, because these are the two countries that are in our set here. UK and France. They are in our set. So country can be UK, country can be France, everything's good there. And city not in the set of London. So if they're from the UK, but they're also from London, we're not going to return that record. If they were from the UK and from anywhere else but London, then we are going to return that record. If they're from anywhere else in Europe, or anywhere else in the world for that matter, besides the United Kingdom and or France, we're not going to return that record at all. Right, so basically if they're anywhere in France, or if they're from anywhere in the UK that's not London, we will return that record. So let's look at that in relation to our database that we're dealing with here. And just for the sake of things, let's go ahead and get rid of this long query here. So we can write select star from players where town not in Stratford. So this will pull back to us everybody who is not from Stratford. So if we should look at this, we should not see any Stratfords here. What about Eltham? Let's ELTHAM. Let's make sure we don't get them here either. Pull them out. Now we can see that they're gone, right? And let's say, let's say they're females that don't meet these, right? We have this sex column here. So let's say it's the females that are not from these two places. So we can add sex in F for female. So that should just give us B. Newcastle, C. Collins, and IP Bailey as our results. Because they are not from Stratford or Eltham, and they are females. Right, so we're just adding a few more tools to our toolbox here. Just to give ourselves a little bit of ability. Now I want to get done within the hour. And I've got nine slots. So I think we are right on schedule, judging by the amount of time we have left here on our clock. So we should be able to go from here. Looking good. So inside a table, a column often contains many duplicate values, and sometimes you only want to list the different distinct values, and that's when we use the distinct clause. For example, one of the instances that we have in our tennis table, which is what we will do as a demonstration in just a few minutes, is that, we have many different places that our tennis players are from, but maybe we only want, we only just want to pull the distinct values from, the towns that they are from. Stratford and Eltham and all of these, British city names that we're dealing with here. So if we only want to unique results returned from our query, we are going to use the distinct clause here, and that will allow us to just pull back something distinct. So, for example, we're going to select distinct country from customers, and that will pull back a distinct list of countries that all of our customers are in, right? So we can see that, we have customers in America, and we have customers in Canada, and we have customers in Mexico, and wherever else, right? So if we look at our example here, we're just going to quickly run select distinct town from players. So that'll just give us a list of distinct towns that all of our players live in, unduplicated list. There it is, right? Like, we've seen the list before. We know, like, if we look at the select star from players that we've kept ran here, we would know that there's a whole bunch of people from Stratford. There's a whole bunch of people from, there's a couple of people from Eltham, right? Distinct just allows us to pull back the distinct name, right? And what else could we do with this? Well, order by town. Put them in alphabetical order. Just like that. Pretty easy. All right, so it just gives us a distinct list of all of our players, or all of our towns our players are from. When we need an unduplicated record, there's a lot of times that we would need something like that, right? Like, for example, that's one of the things that we talk about here at the college a lot, right? Like, students take a lot of courses. So one of the things that we need is we need a record of students who are registered for courses, or maybe students who are registered in online courses. So we have a total number of registrations, which would be your total number of courses that you're taking. But then we would have a total number of unduplicated registered students, right? Because, one student could register and take 6 courses if they wanted to. Might be a bit of a challenge for them, but they could very well do that. One lets us know how many courses are being taken. One lets us know how many students we have, right? So, in this instance, if we were to look at our select star from players, one lets us know how many players we have. One lets us know how many towns are represented quickly and easily. Now, let's look at some mathematical functions. So we do have a few mathematical functions in MySQL that we use to do some calculations on data. And we call these aggregate functions. And we're going to run through several of these. One is a count. And so if we're going to count a specific field, counting whether or not we have data in that field, which is much different than a sum of data in that field, right? Because if I'm doing a sum of data in a field, then I am doing math with numbers that exist, right? Then there are numbers in a field that exist 2 plus 1 plus 3 plus 5, right? But if I'm counting, that's just 1, 2, 3, 4. I'm just counting the number of records that exist. Max field, I can select the max from orders. Or I can just select the max integer or max number from some column, from some record. Min, I can select the lowest amount. Average, I can actually select the average of a group of records, which is pretty interesting, right? So one of the things that you can do So let's play with some of these examples here. All right, so let's look at select star from players, and let's look at what we've got here. So I can see. Let's get a count of all of our players from Stratford. So let's select a count. And in this instance, we can really select a count of literally anything here. Right? We can select a count of name. We can select a count of player number. We can select a count of literally anything because the output doesn't really matter. All it's going to be doing is it's just going to be counting a value. So it's just going to be gathering this value, and then it's going to be counting them. 1, 2, 3, 4, 5. Right? So then I'm just going to use the other tools that we've learned about so far. To figure out the rest of the stuff, right? So I could say where town equals Stratford. So how many players are from Stratford? Oh, I forgot to put in my from here. From players, where town equals Stratford, 7. There are 7 players from Stratford. And if we look at our players table here, we can actually do that count, right? 1, 2, 3, 4, 5, 6, 7. Seven players from Stratford. What is the max lead number, you might want to ask? Like, oh, well, let's select the max league number from players. Right, and then I'll just look through everything in the players table and get the biggest league number. So we can see here, it looks like it's probably 8467. 8467 it is. We can switch that to min, and it'll return us back the smallest league number. We could get both of those in a singular and we could even count. I think this is where I wanted to do that. Count distinct league numbers. I think that works. Let's try that out. There are 10 different distinct league numbers. The smallest league number is 1,124. The largest league number is 8,467. Right? And again, we can go back and check this, right? This is, when you were doing high school math and they were like, go back and check your work. You can go back and check your work here. Right? Okay, so we can check and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so there are 10 different distinct league numbers. They're all different. Right, every single one of them is different. The smallest is definitely 1124. Is that what we said? 1124? Yep. Now we've already said 8467. Cool, right? Now, some of these other tables might be some of the better ones to use for these examples, right? For example, if we look at our penalties table, we can see we have a bunch of amounts here. Right, well, I wonder what, if I selected my sum of my amounts from penalties. What's that going to give me, right? That should give me the sum of all of my amounts, right? So it gave me $480. And if I came back here and added all these up individually, it would probably give me that number. Well, what if I wanted to do it for only for payments that had a certain high payment number? Well, select sum from penalties where, right, we're just adding stuff to it, where payment number greater than 5. So it would give me payments 6, 7, and 8. $130, right? So that's just these last 3. Or I could even just say order by payment number descending, limit 3. Should be another way to do it. Although that's still going to give me all of my penalties there. That's not taking anything out, right? Because I've not given any kind of conditional here for it to limit anything. That's why that doesn't work. So that's a good thought there. And so that gets us to where we want to be today. So we are at the end of our hour. We're at the end of our time. I am ready to wrap up for today. Next week, we will spend time looking at unions. We'll spend specifically time looking at unions. And we will just spend some time writing some different types of queries, just so you can all have a bunch of examples. So with that being said, that's where we'll stop for today. Thank you again for watching. We'll turn on the music for just a moment, just in case anybody who is watching live has any questions. If you are watching the recording and you have some questions, please feel free to email. Thanks for watching. We'll see you next time.